بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. How are everybody? I hope you are okay. Today we will continue the first chapter. Okay, now we'll talk about the dimensional formula. What is the meaning of dimensional formula? It is a formula. Easy, okay? It is a formula. Expresses the derived quantity in terms of fundamental physical quantity. Okay, can you remember the difference between derived and fundamental? Of course, miss. Derived quantity is a physical quantity can be defined in terms of fundamental physical quantity. While fundamental quantity, it is a physical quantity cannot be defined in terms of another physical quantity. Okay, can you remember the example of fundamental? Yes, of course, length, mass, and time. Okay, so we can express the derived quantity in terms of or by use the fundamental physical quantity, which are length, mass, and time. So what is the dimensional formula of length? L capital. Dimensional formula of mass? M capital. Dimensional formula of time? T capital. Power, positive or negative A, B, C, where A, B, C are numbers. Okay. This is important note. If we know is one of physical quantity, mass, length, or time not present, it not exist in our formula. Okay, how can we express that? It's expressed as m power 0 or l power 0 or t power 0. Why? Because any quantity power 0 equal what? Equal 1. So m power 0 that means equal 1, l power 0 that means equal 1, t power 0 that means equal 1. Again, what is the meaning of dimensional formula? It is a formula express the derived quantity to or by fundamental quantity. So if we see any derived quantity, we have to convert it into fundamental quantity to know the dimensional formula of it. Okay, now please focus with me. I will explain different dimensional formula for different physical quantity. Firstly, we'll talk about the area. What is the meaning of area? Area equal what? First, the area denoted by what? Area denoted by A capital. There is difference between A capital and A small, means of course, A capital area, A small acceleration. Okay, well, area equal what? Equal length multiply with L times width, okay? L is fundamental or derived? Of course, L is fundamental. Length, what about width? Width is length also, so it is fundamental physical quantity. So the dimensional formula of length is L capital. Dimensional formula of width of also L capital. So what is the dimensional formula of area? L power 2. Okay, what about volume? Volume denoted by what? Volume denoted by V capital. Also V capital. What is the difference between V capital and V small? V capital, the symbol of volume. V small, the symbol of speed or velocity. Okay, volume equal what? Volume equal length time width time height. So what is the dimensional formula of volume? Dimensional formula of length is L because it is length. Dimensional formula of width, it is length also. Dimensional formula of height, length also. So dimensional formula of volume equal what? L multiply L equal L power 3. So the dimensional formula of volume L power 3. What about density? We studied it in first prep. Do you remember that? Density, sorry for that. Density denoted by rho. Rho equal mass over volume. Okay, mass is fundamental or derived? Mass is fundamental. Okay, it's easy. What about volume? Volume is derived quantity, so we can convert it to fundamental physical quantity. So we can know now the dimensional formula of mass is what? M or L or T. Of course, it is M mass. Okay. M capital. What about volume? We'll study it now. The dimensional formula of volume L power 3. Can we write the dimensional formula as a denominator like this? No, we need to rise it up. Okay, so when I write it up, okay, we have to change the sign from positive to negative. So the dimensional formula of density equal what? Equal L ml power negative 3. Okay, so again, what is the dimensional formula of area? L power 2. Dimensional formula of volume? L power 3. Dimensional formula of density? L ml power negative 3. Okay, what about velocity or speed? Velocity equal what? Sorry. It is denoted by what? Okay, V small, not V capital, because V capital is volume. Okay, velocity or speed equal what? Equal displacement over time. Okay, displacement is fundamental or derived. Displacement is fundamental. It's easy. Okay, time fundamental also. Okay, we can write the dimension formula now. Distance, meters or length or time. Of course, length. So L over what time? T capital. Can we write dimension formula like this? No, we can write the time up. So equal L T power -1. What about acceleration? Acceleration denoted by A small. Equal what? Equal velocity over time. Okay, what's the dimension formula of velocity? We study it now. L T power -1 over T capital. Okay, we need to raise it up. So equal what? Equal LT power -2. Okay, another quantity, please. Okay, just a second. Okay, we need to raise it now to complete our physical quantity. We studied area L power 2, volume L power 3, density M L power -3, velocity or speed LT power -1, acceleration LT power -2. What about force? Force equal what? Force equal mass time acceleration. Okay, let's know now what is the meaning, what is the dimensional formula of force. Force equal what, guys? Force equal mass time acceleration. Okay, mass is fundamental or derived? Fundamental. Okay, what about acceleration? Acceleration is derived, so we have to convert it to fundamental. So equal what? The dimensional formula of mass is M or L or T? Of course L. What about acceleration? We studied it now. L T power -2. So the dimensional formula of force equal what? MLT power -2. What about work? Oh yeah, work equal force multiply displacement. Work equal force multiply displacement. So what is the dimensional formula of work? Okay, it equals dimensional formula of force multiply dimensional formula of displacement. Dimensional formula of force equal what? M L T power -2. What about displacement? It is L. Okay, let's collect lengths together. Equal what? Equal M L power 2 T power -2. Okay, so we can now determine the dimensional formula of what? Of every quantity. Every derived quantity we can convert it into fundamental and explain or determine the dimensional formula. Number 1, area length multiply width L power 2. Of course, unit equal M power 2 meter square. Volume equal length multiply width multiply height equal L multiply 8. So it's a dimensional formula of volume equal L power 3 and the measuring unit equal meter power 3. Density equal mass over volume equal M over L power 3. So it equal ML power -3. What is the measuring unit of density? M mass kilogram, L meter power 3, so per meter power per meter square. Sorry, meter power 3. Okay, okay. I have a note here. We can write the unit kilogram per meter power 3, or we can write kilogram dot meter power -3. In unit, we can write the unit with both way. Okay, but in dimensional formula we have to write ml power -3, but here in unit we can write kilogram per meter power 3 meter cube or kilogram meter power -3. Okay, what about velocity? Velocity equal displacement over time, so dimensional formula lt power -1 and the meter equal m second, or we can write ms power -1, write it out. Okay, acceleration denoted by A equal velocity over time. So dimensional formula equal LT power -2 and the measuring unit M per second square, or we can write meter, okay, S power -2. What about force equal mass time acceleration? So the dimensional formula of mass m, acceleration LT power -2. So the dimensional formula MLT power -2. Okay, so the measuring unit of mass kilogram, L meter times second. So the measuring unit of force kilogram meter per second square, or Newton, related to the scientist who discovers the force. We can write the measuring unit kilogram meter per second, or we can write kilogram meter second power -2. Okay, what about work? Work equal force multiplied displacement. So the measuring unit of work ml power 2 t power -2. The measuring unit, the dimensional formula of work ml power 2 t power -2. The measuring unit of work equal kilogram meter power 2 second power -2. Or we can write it kilogram meter power 2 per second square. Or we can write the measuring unit of work joule related to the science who discovered the unit of work or discovered the work. Okay, guys, I hope you understand now the meaning of dimensional formula. As a last point, you have to know why we study the dimensional formula, because the dimensional formula verifies the validity of equation, help us to verify the validity of equation. How can it verify that? Okay, if I have example now, prove that the following relation is dimensionally correct. Kinetic energy equal half kinetic energy, we know from first break, equal half mv squared. Okay, given that dimensional formula of energy اللي هو يعتبر right hand side equal this is left hand side. Okay, wait please. Kinetic energy is left hand side. Okay, equal ml power 2 t power -2. Okay, if the dimensional form of mv power 2 equal ml power 2 t power -2, so the equation is correct. If the dimensional formula of mv power 2 doesn't equal ml power 2 t power -2, so the equation is wrong. What about half? What's the dimensional formula of half? The number has no dimensional formula. There is no dimensional formula for the number. Okay, so now we need to know the dimensional formula of right hand side, which equal mv squared. Okay, dimensional formula of m is mass, so it is fundamental quantity. So the dimensional formula is m capital. What about velocity? Velocity law equal displacement over time. So velocity square equal displacement over time square. Again, velocity square equal displacement over time square. So the dimensional formula of velocity square L power 2 divided by T power 2. So the dimensional formula of mv square equal m capital L square over T square. Can we write the dimensional formula like this? No, so we can raise it up. So the dimensional formula of kinetic energy, mv power 2 equal m L power 2 T power -2. Okay, if both sides have the same dimensional formula, so the equation is correct. While if the both sides have different dimensional formula, the equation is wrong. Now we find out the dimensional formula of kinetic energy is the dimensional formula of mv power 2. So the equation is dimensionally correct. Dimensional formula of kinetic energy equals the dimensional formula of mv power 2. So the equation dimensionally is what is correct. I hope you understand now what is the meaning of dimensional formula, and you know the importance of dimensional formula, which it used to validate to verify the validity of equation. Okay, and we can know the measuring unit from the dimensional formula as we studied before. Okay, guys, I will see you later, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.